Hello everyone, welcome to this demo on auto migrating EC2 databases to Amazon Aurora using AWS Database Migration Service. I'm Vamsipita, I'm a solutions architect at AWS. This feature was announced at reInvent 2024 and it fits a use case where if your organization is rapidly growing in terms of database size and would like to migrate to either Amazon Aurora or Amazon RDS to improve scalability, performance, availability, and would like to leverage automated backups feature. This one-click move to managed database feature will make it seamless to migrate your databases hosted on EC2 onto Amazon Aurora or Amazon RDS. In this demo, I'll be showing you an example of migrating a PostgreSQL database. However, you can use a similar process for MySQL as well. And you can either select Amazon Aurora or Amazon RDS as a target following the same process. First, I'll start by enabling logical replication on Amazon EC2 database, which is the source in this case. Next, I'll create a new database cluster parameter group and enable logical replication in that cluster parameter group. I'll be using this new cluster parameter group to create a new Amazon Aurora database cluster, which will be the target in this scenario. Finally, I'll initiate data migration from the source, which is the EC2 database. There are a few limitations to this feature as of now. First of all, the target database status must be available to begin the source database migration. Then, if you're doing this for MySQL, you need to have a replication admin role for the Aurora account. Both your EC2 instance and the target database must be in the same VPC. As of now, there are few database targets which are not supported, and you can find them here in the list. Let's dive into it. I'm in the AWS Management Console. I have two EC2 instances currently running. One is hosting my PostgreSQL DB. I also have a Windows machine, which I'll be using as a gem box. Since my PostgreSQL database is running in a private subnet, I'll be using the Windows gem box, run pgadmin on the Windows gem box to connect to the PostgreSQL database. Just a quick glance at the current database. Here is my pgadmin running on the Windows gem box, and I have added the EC2 instance, which is hosting the database. For demo purpose, I have used a sample data, which is a DVD rental. So you can see that database here. It does have few tables. So let's explore that. So as you can see, there's some sample data here. And the idea is to use the one-click migration feature to copy over this data onto the new target Amazon Aurora PostgreSQL database. So process-wise, let's connect to the EC2 instance first to enable the logical replication. Let's log into PCCO and check the current WAL level. Currently, it's set to replica, and we should update this to logical to enable the replication that we're going to do in the demo. For that, let's run the command. After this, let's restart PostgreSQL to make this into effect. Once you do that, let's log in again to verify the update. Currently, it's showing logical. So our step 1 is done. We'll move on to step 2, which is creating a new database cluster parameter group. Let's jump back into our EC2 instances. Search for RDS. Navigate to parameter groups. Let's create a new parameter group. I'm going to give it a name, custom parameter group, PostgreSQL 16. For engine type, I'll select PostgreSQL. Parameter family, let's do 16. And for type, select DB cluster parameter group. We want to enable this at the cluster level. Once you create it, click on the parameter group and click edit again. Search for RDS dot logical replication and update it to 1. This flag will enable logical replication, which is similar to what we did earlier by logging into EC2 instance and setting the WAL level to logical. Save changes. Now let's go back to dashboard and create a new database. We'll follow the standard create process, and Aurora is already selected. On the source machine, I have PostgreSQL 16.5 running. For the target, I'll select 16.6. Since this is a demo, I'll be following configuration best practices for dev and test. Give it cluster identifier, PGSQL 16.6, Aurora. I'll use AWS Secrets Manager to manage the database credentials and leave most of the other configurations as it is. I'll select T3 medium as the database instance class. I'll skip the multi-AZ deployment since this is a demo, but it's highly recommended for production workloads. I'll choose public access as no. Since the source database is also running in a private subnet on EC2, I will replicate the same and assume that we need private access for this database also. Security group, I'll select an existing security group, which is also attached to the source database. Scroll down to the bottom. Under additional configuration, we have to select the DB cluster parameter group, which we created earlier. So now this is an important step which will enable that logical replication. If you miss to do this now, you can again modify. Once the database is created, you can go back and modify and select this custom parameter group later. We'll leave everything else as it is and create the database. This process will take a while. I'll stop the recording and come back when the database is successfully created. Our target database is now available. Let's view the connection details for the endpoint. Copy that, and you can retrieve the password from the secrets manager. I'm switching to pgadmin to add this new server. I've pasted the password from secrets manager and added the endpoint as well. All right, we are now connected to our new target Amazon Aurora PostgreSQL database. As you can see, we don't have the DVD rental database yet. So let's go ahead and create the database. All right, as of now, we don't have any tables in this. We'll use the one-click migration feature to copy the data from the source to the target. Let's switch back to the console. Over here, select the database cluster, click on Actions, and click on Migrate Data from EC2 Database. Let's choose the EC2, which is hosting the PostgreSQL, and provide the database which it needs to copy. I'm going to use an option to create and use a new secret for the source credentials, source database credentials. I'll choose to create and use a new IAM role to access the secret. For the target database details, let's provide the database name, which is DVD rental. Again, we'll select the option to create and use a new secret. Oh, sorry, for the target, since the secret is already created, we'll use the existing one. We'll, we'll use the option to create a new IAM role for accessing the secret. And I'll provide a name, source, target. In this case, I'm going to select a full load option. You can also choose full load and change data capture option for an ongoing replication. For the demo, I'm going to use the full load. I'll again choose to create a new IAM role for the data migration. Now, this IAM role will grant a database migration service required permissions to access AWS resources. Let's click on Acknowledge and click Migrate. While this is in progress, if you click on the instance itself, you'll see a tab called Data Migrations, which is where these new resources related to this migration will be created. You can see that a new data migration project is kicking off. Depending on the size of the data you have, it might take a while for this process to finish. I'm going to stop the recording and come back when it's fully done. I'll show you all the things that it will do in the backend to finish this migration. Migration is now complete. Let's go take a look at what are the different things happened in the background. We'll start by clicking on the migration project itself. Over here, you can see details like how many tables were loaded, uh, how much time it took, and what number of jobs ran for doing this process, and a few important details like data providers. If you go to this data provider section, you will see both source and destination as are added as data providers, and even an instance profile was created, which is used to access the instances. Since the data is now complete, let's go check out the logs to find more details on the process happened in the background. So a few things I want to highlight here is, um, first of all, it tries to make a successful connection to the source database, followed by the destination, the target database. Then it launches the migration um, for each table one by one. So you'll find more details in these logs, and if any errors pops up in the migration, you can find them here. All right, now it's time to check the data in the target database. So for that, let's switch to pgadmin. Over here, since we are already connected to the Aurora PostgreSQL, I'm going to click refresh and then see if our new tables appear in the destination. As you can see, there are 15 tables copied over. And just to make sure, I'm gonna check the data here. Now, using this one-click feature, without changing anything in the source, we were able to copy the data from source to destination seamlessly.